So we were talking here about distance. Well, we had also mentioned earlier about proper motion of stars. And the symbol for proper motion is a lowercase Greek mu. And so we want to figure out, well, there's a relationship between how fast something is really moving, how far away it is, and how fast it looks like it's moving. For example, if you go stand outside and look at an airplane fly overhead, it looks like it's moving pretty slow. Well, it's not moving slow. It's moving very, very rapidly. But it looks like it's moving slow because it's a long ways away. It's a long ways up. The International Space Station moves even faster, but it doesn't look like it's going all that fast in the sky because it's even farther away. So there's a relationship. The relationship is that if you multiply mu times the d, now the mu must be in arc seconds per year and d must be in parsecs. So mu has to be in arc seconds per year and d has to be in parsecs. And if you multiply this together, remember you get d as 1 over parallax, then the answer is how many AU per year. If you multiply that by 4.74, that's going to give you how fast it's moving in kilometers per second. So let's look at this table of data right here. Let's look at the star BD plus 15 degrees 2620. And we notice it has a parallax of 0.184. Okay. And it has a proper motion of 2.298. So let's look at the star BD plus 15 degrees 2620. As I said, the parallax is going to be 0.184 arc seconds. And the proper motion was 2.298 arc seconds per year. And so I want to know how fast is the star actually moving through space. So the velocity is mu times d. Well, d has to be in parsecs. Well, that's easy. That's 1 over parallax. So that's 1 divided by 0.184. Okay, so 1 divided by 0.184 is going to give you the answer in parsecs. And that turns out to be 5.43 parsecs. So the distance is going to be the actual speed through space is 2.298 times 5.43. Okay. And that comes out to be about 12.5 AU per year. Remember, 1 AU is the distance that Earth is from the sun. So that means this star is flying through space at about 12.5 Earth-Sun distances every year. And so that's going to be the motion here. If I want to find out how fast that is in kilometers per second, it's 4.74 times that quantity. Okay. So that's going to be equal to about 59.1 kilometers every second. So that's how fast this star is moving. That many AU per year, that many kilometers per second flying through space. Now, that's the side-to-side motion. So here we are on Earth, and we're looking at the star, and we see the motion like that, but we're not seeing any motion towards us or away from us. It could be actually moving at an angle like that, so it's all we're seeing is the side-to-side part of it. So the motion could be actually more complicated than it looks like here. And generally it is more complicated than it looks like. And so we have to somehow figure out this other motion that's in there as well. But this is an example here of how to use the proper motion to find the motion in space, or we call it the tangential motion, because we're just finding the motion that is perpendicular to our line of sight. So this is the side-to-side motion that we're finding.